Mm-hmm. Okay, so I was everyone come to this thing?
Yeah.
Okay, so if you think back to Thursday, what we did was you guys added and subtracted polynomials. We're still going to have a polynomial. So the title says multiply a monomial by a binomial and DCF.
No.
Very slow factor. You guys learned that. So in order to multiply monomials by binomials, we have to use very common factor. When we start getting into factoring, and that will make more sense for the rest of the big thing called factoring, which is very important to our student ministry. So keep that in mind. Okay, so monomial means you have one term. Binomial means you have two terms. And we'll do some trinomials as well. So you're multiplying one term times something with more than one term. Is essentially what that is. So here are your rules to be able to do this. So the first thing you're going to do is use the distributive property. So what that means is you multiply your coefficients together, and then you add your exponents. So we're going to refresh your memory on this, first of all, on these examples. So we did this at the very beginning of the semester. You guys multiplied together exponents. You remember? It was like January when we did this. So x squared times x to the fourth, what does that equal?
X is 6.
X is 6. You add exponents together. So my answer here is x is 6. Go ahead and try number 2 and number 3. I know. Okay, check your answer on number 2. You should have gotten an 8 of the 9. Yes, you're just adding exponents. Now number 3, looks like some of you got it and some of you are stuck. So you're multiplying together the like terms that you have, quote unquote like terms. It's not really like terms, but it's kind of like that. So you would multiply together your a's and then your b's. So if I multiply together a squared times a to the fourth, what do I get? A to the sixth. And then if I multiply together b to the third times b to the fifth, what do I get? B to the eighth. I add those together. So I get b to the eighth. And there's my simplified form. Okay? Do we remember this? And what'd you say? Yes, you have not learned this yet. Number 4, you haven't learned that yet. We're going to learn it right now. But number 1 through 3, you should remember from the beginning of the session.
Yeah.
What do you mean?
Because you're multiplying them, but you're adding.
Are you talking about number 4?
No, I'm talking about number 2.
On 3? There's no addition sign.
No, like why isn't there?
No, you're just multiplying all those together. That bullet means you're just multiplying. Okay, gotcha. Okay, so on number 4, now, this is where you're going to use these steps. So if you look at these steps, we're going to use the distributive property. When we do that, we multiply together our coefficients, and then we add exponents of like variables. So on number 4, you have 5a squared times, and then you have this called a trinomial, because there's 3 terms in there. You have negative 4a squared, you have 2a, and you have negative 7. So what you're going to do is you're going to distribute that 5a squared through to everything. So I'm going to multiply 5a squared times negative 4a squared. I multiply 5a squared times 2a. And I multiply 5a squared times negative 7. So when I multiply these together, if I'm multiplying, first of all, 5a squared times negative 4a squared, first I multiply the coefficients. So 5 times negative 4 gives me negative 20. And then I do the like variables. So a squared times a squared, what does that give me?
A4.
A to the 4. So that's my first term. Then I distribute 5a squared to 2a. So first I do the coefficients. 5 times 2 gives us 10. I'm going to add 10 because it's a positive 10. And then a squared times a gives you what, Lane?
A to the third.
A to the third. Then we do the last one. So 5a squared times negative 7. I multiply the numbers first. So 5 times negative 7 gives you negative 35. And then a squared, there's nothing to multiply with. So I just tack on that a squared to it. And you don't have any like terms there. If you have like terms, you can multiply them together. But in this case, there's no like terms. A to the fourth, a to the third, and a squared, those are not like terms. So we have simplified it now. Right, questions so far on the first problem. Okay, let's do letter or number 5 together. So same idea here. The difference here is now you have 4 terms in your parentheses. We're going to do the same thing. Distribute that negative 6d to the third through to every single one of those terms. You're going to multiply it 4 times. So negative 6d to the third times 3d to the fourth. First of all, look at the numbers. So negative 6 times 3 gives us negative 18. And then d to the third times d to the fourth, what does that give us?
Negative, D.
D to the seventh. Add them together. 3 plus 4 gives us 7. Then we move on to the next one. So negative 6d to the third times negative 2d squared. Or to the third, excuse me. So first my numbers, negative 6 times negative 2 gives you positive 12. So I'm going to add 12. Then I have d to the third times d to the third, which gives us d to the sixth. Then moving on to the next one. Now you have negative 6d to the third times negative d. You can think of it like there's a negative 1 there. So negative 6 times negative 1 gives you positive 6, so plus 6. And then what is d to the third times d? D to the fourth, because it's like this is d to the first, so you've got to add that 1 to it. Okay, then negative 6d to the third times 9, all you got to do is multiply the numbers. So negative 6 times 9 gives you negative 54, and then I tack on that d to the third. Okay, so far so good? Yeah? Okay, I'm going to skip number 6, actually, because this gets a little mundane. Look at number 7. What's different about how number 7 looks? You're multiplying just a variable. Yes, what else is different? Daniel? Oh, I thought you said something. Okay, at the beginning, there's no number to distribute. What else is different?
There's only 2 things in the parentheses.
There's only 2 terms in parentheses, and what's special about the number of parentheses you have?
2.
There's 2 sets of parentheses now, okay? So in number 7, that means we have to distribute 2 different things. So in this first set here, I'm distributing x through to that first set of parentheses. So x goes to 3x squared, and x goes to 4. Then in the second set of parentheses, I'm distributing that to 7x and negative 3. Okay, so if I distribute that x through, I get what, Tristan? 3x cubed plus, what comes next?
4x.
4x. X times 4 gives you 4x. Then if I distribute that 2 through, I get 2 times 7x gives us what?
14.
14x. And 2 times negative 3 gives you
Negative 6.
negative 6. Are we done?
No.
Why not?
We can simplify.
We can simplify. How can we simplify?
4x plus 14.
Yeah, add those left terms that are in the middle. So I have 3x to the third at the beginning, and then 4x plus 14x gives you 18x, and then minus 6. That would be your simplified form. All right. Try number 8 on your own. Finishing up, check your answer up there. This is one where you have to combine like terms when you multiply it through. Questions on that one? Good. Okay. We're gonna skip number 9. Let's look at number 10. This is the complicated one. Okay. I'll go through this one with you. Now you also have 2 sets of parentheses. So you're gonna have to distribute twice. But now you also have 2 different variables. There's n's and there's p's. So when I distribute, I'm going to distribute this 4n through to everything in that first set of parentheses. I'll start with just that first set of parentheses. So if I distribute that 4n through, I have 4n times 2n to the third p squared. Almost. So first I do my coefficients. 4 times 2 gives us 8. And then I multiply together the like variables. So I have n times n to the third. What does that give us? N to the fourth. And then p to the second. There's nothing to multiply that p by, so I leave it as p squared. Then I do the same thing with the next term. So 4n times 3n p squared. So my coefficients, 4 times negative 3 gives you negative 12. Then I have n times n gives us n to the second. And then I have p squared. There's nothing to multiply that by. What does my last term end up becoming? 20n squared. Very good. Okay. So plus 20 is your coefficients, and then n times n is your n squared. Okay, then we're going to do the same thing with the next set of parentheses. So now I'm distributing 4p through. One of those. So 4p times 6n squared p. So do my coefficients first. 4 times 6 gives you 24. Is there anything to multiply that n by? No, so I just write n squared. Try to keep it in the same order. If you start going n and then followed by p, try to keep doing that throughout. It'll make your life easier. And then p times p gives us p squared. Then I do the same thing. 4p times negative 2np squared. 4 times negative 2 gives you negative 8. There's nothing to multiply that n by, so it's just n. And then what is p times p squared?
P cubed.
P cubed. What does my last term become? 12p squared. Good. Do I have any like terms?
Yes. All the p's.
What's tricky about this one though?
You have to combine the whole thing.
You have to yeah, the whole thing has to be the same. The n exponent and the p exponent has to be the same.
So what's the 12?
Excellent. These are your only like terms. Negative 12n squared p squared and 24n squared p squared. Because the n has a squared, the p has a squared. Both of those things have to be true. So I'm going to go in order across now. I start with a 8n to the fourth p squared. If I combine my like terms, then what do I get? 12. So I add 12n squared p squared. And since those are my only like terms, I can fill in the rest from there. So I have plus 20n squared minus 8n p to the third plus 12p squared. Okay, questions on that particular problem? I know that for greatest common factor, here are your rules to find the greatest common factor. You guys did this probably even going back to elementary school, but we'll refresh your memory. So to find your greatest common factor, you have to factor down all your numbers, and then you multiply it into like factors they have in common together. So if we look at 5 and 40, first of all, 5 is already prime. You can only multiply 5 times 1 to get 5. But I can factor down 46. What are two factors of 40?
10 and 4.
10 and 4. Okay, so that's 10 times 4. 10 is not prime. What are some factors of 10? 5 and 2. And then 4, 2. Okay, so 5 and 2 are both prime factors. So now let's factor them. So after I factored them, it says multiply those factors both numbers have in common. Okay, so in this case, 5 is just the number 5. That was prime factor. 40 also has a 5. Those are in common. Both of those numbers have a factor of 5 in them. So that means your greatest common factor is 5. You can ignore all the other numbers. Number 2 is a little bit more complicated because now you don't have just one prime number. So what is 20 split up into? 10 and 2. We know 10 splits up into 5 and 2. What is 48 split up into? 8 and 6. 6 goes into 2 and 3. What are factors of 8?
4 and 2.
4 and 2. And then 4 we know is 2 and 2. Okay, so what do they have in common?
2.
They both have 2 2s. So I have 1 2 here, 1 2 here. And I have 1 2 here, and 1 2 here. So I'm going to multiply those together, the 2 that are in common. 2 times 2 means my greatest common factor is 4.